And welcome everybody to the Daily Space Weather. Coronal mass ejections, large sunspot groups, and more to cover today. First thing we'll look at is the closest star. The cause of your space weather. This is composite imagery from the SDO, colorized magnetogram, and 171 angstroms. The most activity we've seen over the past 24 came from this area down here, sunspot 2877, sunspot 2880. Still quite significant, having remained stable over the past 24 hours. Here it is in some different wavelengths, 304 and 171 angstroms ionized helium and iron. Also from the SDO. Let's talk about the coronal mass ejection that occurred late last night. So here's the viewpoint from Lagrange point 5, the location of stereo A, and Lagrange point 1, the location of the LASCO instruments. So here's stereo A and the LASCO C3, and you can see we've got a coronal mass ejection here. Part of the reason why we put up a warning is because we've determined that we're able to forecast coronal mass ejections. For you new viewers out there, we only do it on the Earth vicinity. So basically just this area here, not this area. Yes, this area. And that includes this area on the LASCO C3, and it all has to do with perspective. Again, LASCO is located here at Lagrange point 1, stereo A is located at Lagrange point 5, putting the Earth off to your right. So this could be an Earth-facing coronal mass ejection, but we see here on the LASCO that we're expecting it to miss Earth to the west. Great example there of a coronal mass ejection that is lined up with the Earth in terms of the ecliptic plane, which is about here around the solar equator, but too far to the west to strike the Earth. In this case, it came from sunspot 2877, which is this one down here that's in a setting mode. Solar flare warning continues, and we're not sure about the coronal mass ejection watch. We have to wait until this one's completely done unfolding yet. It could still produce additional coronal mass ejections. Anyway, there's the colorized magnetogram. Here's 304 angstroms. And you really can't see the coronal mass ejection very well. There's a small prominence that you can see right in this area, sort of ahead of sunspot 2877. The radial flux has dropped down to 91. And by the end of the day today, we should see only one major sunspot group, assuming no new ones form. There's the black line. That's the radial flux over the past year, as reported by Solon.info. And here's a space weather enthusiast dashboard. NOAA just forecasted expectation of a KP4. And it's because there's another coronal hole wind stream arriving at the moment. And it has a strong negative Z component in the BTBZ portion of the solar wind data. We'll get to it in a minute. First, global seismicity. We did see a 7.3 magnitude quake near Vanuatu come in just a few hours before we made the video. So let's scroll up the list here. It was quite a significant quake. There's a deep quake at Timor-Leste. That one occurred yesterday at 1342 Universal Time. We saw lots of deep quakes in yesterday's Daily Space Weather video report. Deep quake in the Aleutian Islands there, a 4.7 magnitude at 130 kilometers depth. Papua New Guinea had a 5.4. That is one of the largest of the past 24. Tonga saw a 5.7. And this 7.3, if that occurred at the surface, that would be like an 8.5 magnitude quake. Fortunately, it occurred at 535.8 kilometers estimated depth at 6:29 Universal Time this morning. So there's the largest quake of the past month or so. A little under a month. No, largest quake here in like 2.5 months. So it's that 7.3 at Vanuatu. There was a tsunami advisory that went out, but we're not expecting to see any tsunamis generated from this as it is so deep. Surface quakes much more likely to generate tsunamis than deep quakes like this. Volcanoes continue to uptick here over the past 24. Here's one that's literally called Volcano in the Aeolian Islands of Italy. Fumarolic activity, increased carbon dioxide and sulfur dioxide emissions. A small internal tremor recorded at a seismic station, and they've raised the alert level to yellow for Volcano. La Palma, still producing a 10,000-foot plume of volcanic ash. The ocean entry remained active, but seemed to lose power. I think they mean lose power during the evening, and maybe even stopped to be alimented. Suminosejima exploding, 12,000-foot ash plume over the Ryukyu Islands. Luatolo now on the list. Occasional strombolian activity over the Lesser Sunda Islands. About a 3,200-foot plume of volcanic ash from Luatolo, Kilauea, producing an effusive eruption. Fountaining continuing at 2 locations. On the Big Island of Hawaii, in the southern flank of Kilauea region. Lava fountainings. The new lava lake has been rising, another about 4 meters over the past 24 hours. Popocatépetl in central Mexico, volcanic ash not observed in satellite. Don't assume it's not erupting. Fuego exploding, 15,000-foot ash plume over Guatemala. Revenador exploding, 15,000-foot ash plume over Ecuador. And Sabancaya exploding, 24,000-foot ash plume over the nation of Peru. A prime example of why not to pole vault the caldera. What you should do is check out our links below the video. Perhaps pick up our most popular product, the HIPAA, My Vaccination Status is None of Your Business product. I've got the classic tea in orange because nothing says don't run me over or shoot me like orange-colored clothing. And as fall arrives, it's becoming more and more relevant. Did you know that we're on BitChute? Have you seen our latest BitChute exclusive? Wearing a mask in public? Go home, you're sick, to those expecting me to wear a mask. BitChute.com/smashamash. Thanks to our YouTube subscribers. Congratulations on realizing our channel exists. The algorithm probably didn't help you. You probably typed in the URL manually, youtube.com/smashamash. Check out the playlists, youtube.com/smashamash/playlists. There's lots of stuff besides space weather. Next, thanks to our patrons, who used to be the true source of funding for the content, we've switched our Patreon to smashamash.com/smashteam. We've gone independent because we need additional capabilities. So join the Smash Team if you'd like to see all kinds of additional content. Patreon couldn't handle us. We wouldn't fit inside their box, so we had to build another box. smashamash.com/smashteam. There's a bronze level, a silver level, a gold level, and an annual paid-up gold level with complimentary merch. Welcome to the Neo-Renaissance. You can find links to all this stuff like the merch, the forum, and the Smash Team right on our homepage at smashamash.com. Also, thanks to our Twitch followers. Maybe install the mobile app. Twitch.tv/smashamash is the URL. If you're viewing this video, you can probably visit the website. Look for more live streams coming soon. GOES magnetometer showing very low readings here. Low highs and low lows. As there is a bunch more plasma in between Sun and Earth. And some of it is arriving now. Also, we see the GOES 16 and GOES 17 readings diverging at the moment. You can see the GOES 16 rising while the GOES 17 falls. An indication some irregular plasma likely showing up in the geospace. Next, looking at the polarity of the heliospheric current sheet, you can see Earth is in a North Pole current sheet. And that may suddenly change here, as the magnetic environment suddenly can. Magnetism is what rules the solar cycles. Keep in mind this data was 1 hour and 18 minutes old when we recorded the video. Here's a line-of-sight view of the same data, essentially. It also shows you the solar magnetogram. Quite a lot of magnetic organization happening on the Earth-facing portion of the solar disk. Here's the coronal hole line-of-sight plot. And those blue lines there are the potential field surface source of the Sun's B field. Magnetism rules the solar cycles, folks. Now, we've forecasted an increase in coronal holes, and you can see it happening before your very eyes here. This green transequatorial coronal hole associated with the North Polar Field. You can see it's rotating in. So lots of coronal holes and more in our future. Here's the best visualization we can get of coronal holes. It's 193 angstroms. And you can see the South Pole-oriented ones are quite well defined. The North Pole-oriented ones are still sort of covered up by some plasma, but the magnetism doesn't lie. It shows us what's going on beneath all of that plasma. Solar flare warning continues. The likelihood of major flares, very likely from sunspot 2877. And this data over here is a little bit old. But again, solar flare warning continues. I'll just say coronal mass ejections are occurring at the moment. The one that we showed earlier may not be done unfolding yet. We'll have to keep an eye on that throughout the day today. And when I say ion, well, the pun is intentional. Here's the GOES X-ray flux over the past 3 days. No major flares. We haven't seen a C-class flare since September 30th, so no major flares yet in October. But you can expect to see some. That's why we have a solar flare warning. No spikes in the proton flux. No relativistic particles have been striking Earth's geospace recently. And here's a real-time solar wind. You can see another coronal hole wind stream showing up here. It's looking pretty diffuse, having only reached about 14 protons per cubic centimeter. And when we see that drop, we can expect to see the solar wind speed rise once again, which is already elevated at 440 kilometers per second. The main story here is the BZ component. You can see we have this strong, consistent BZ component, and that is capable of producing geomagnetic unrest by itself. When we see the solar wind density drop and the solar wind velocity rise, if that BZ component, that red line in the top frame there where my arrow is, if that remains at -6 as it is now, that's a very strong South Pole orientation, and that could cause geomagnetic unrest. That's what NOAA's forecasting. Here's the KP index over the past 3 days. Again, when the solar wind high velocity portion shows up, NOAA and I'm agreeing on this one, that we may see a KP4, maybe even a mild geomagnetic storm KP5 event. We're going to show the velocity, the density, and the pressure of the geospace here. So sit back and enjoy this visualization by the Space Weather Modeling Framework, courtesy University of Michigan. This is your plasma velocity. And those high velocity areas around the geospace there, those are portions of solar wind reintegrating into the outer solar wind, the solar wind not directly surrounding Earth. Here's a density. This is showing you high density in dark blue, low density in white. And this is just simply plasma density, protons per cubic centimeter. It looks like we see some dropping of the density here, followed by a raising of the density, and that's the arrival of the coronal hole wind stream shock front, the coronal hole high-speed stream, typically always preceded by a high-density portion of plasma. Here's the magnetohydrodynamic pressure over the past 4 hours. Each one of those frames is 4 hours of data, folks. If you want to figure out where it's derived from, head to the Geospace Magnetosphere Movies, click on the Details tab, and click on the Space Weather Modeling Framework. You can read all about it. We'll also look at ground magnetic perturbations and auroral forecasts as we're seeing this perfectly timed little uptick here in geomagnetic activity. We're seeing some magnetic pulses coming out of the central Indian Ocean and so on here. So some magnetic activity kicking up as another coronal hole wind stream arrives. Again, that's 4 hours of data like the last panes. And here's the 30-minute auroral forecast. We'll let this play through one run. Again, if that BZ component remains strongly negative as it is now, when the high-speed portion of the coronal hole wind stream arrives, we could see an uptick in aurorae. Right now, pretty calm when it comes to auroras. They're a minor intensification right at the end of the 30-minute aurora forecast. Next, the diagram of the solar system. Mars is looking lonely. Here's where stuff is now. Let's advance it 1 week. And there's where things will be on October 9th. Here's a star chart from in-the-sky.org. Mine faces the south and includes the ecliptic, which is that yellow line, and also the galactic plane, which is the blue line. And the moon is out there. If I would go out and look, I would see it. Today's cosmology segment is going to be very short. Have you noticed cosmic level debacles? I certainly have. Here's the astronomy picture of the day, and it includes zodiacal light. So the ecliptic plane, which is the plane that the planets orbit on throughout the solar system, is the dustiest portion of the solar system. And if you have great visibility of the night sky, you may see zodiacal light. Here's Venus, bathed in zodiacal light. It's the light reflected by the dust of the solar system. You can go check it out yourself. It's a great computer desktop, perhaps, at apod.nasa.gov. 18 months of the COVID-19 pandemic, scamdemic. Are we doing anything right? The answer is not really. There's a SciTech Daily article about it. I'll let it scroll here. What a pathetic, infantile, and ridiculous response to a virus. And I ask you, the viewer, where did the flu go? Did the flu go on vacation? Was it eradicated by COVID? How could that possibly be? That's today's cosmology segment. And it's beginning to irk me. Next, we'll take a look at charging hazards, and we don't see any at the moment. Let's take a look at the electron flux. Here's the 1-year chart, and it dropped as we forecasted yesterday. That's a 1-year chart from Solon.info. Here's a 3-day chart, and we can expect to see low levels once again here as measured by the GOES 16 and GOES 17. Here's the forecast model. And I would tend to think that this is going to be around where we saw yesterday. Again, since there's another coronal hole wind stream apparently arriving now. Although this one looks a little weaker than the last. Here's a diagram of Earth Van Allen belts. Feel free to pause the video. Distances are shown in miles. Here's the total electron content forecast showing you the most likely spots of GPS errors. The redder those blobs get, the more likely you are to see a GPS error. Most GPS errors occur around the equator at noon. This also gives us insight into oddities in Earth's magnetic field, everything looking fairly organized at the moment. Here's another diagram of the atmosphere showing you where the F ionosphere layer is. It's at about 300 kilometers of altitude, and here is the ionogram animation. High-frequency anomalies and low-frequency anomalies over places like the Central Pacific Ocean, but mainly high-frequency anomalies at the moment. We'll show you those also. First, here's the latest image on the ionogram. That's 10:45 Universal Time. Looking a little anomalous at the moment. And here's the anomaly map showing you departure in megahertz from the 30-day median. Significant high-frequency anomalies over places like the Central Indian and Central Atlantic and Central Pacific Oceans, just south of the equator, which is where you'd expect to see them as it is now fall in the Northern Hemisphere, which means the sun is slightly south of the equator. Anyway, here's the latest image. That is from 10:45 Universal Time. Ionogram anomaly map. smAshtober has been a delightful month so far. What do you have to say? Have you seen our meteorology segment? We premiere them before the daily space weather video. Here come bonus features. First, the El Teide Spain ground-based solar observatory. Hydrogen alpha imagery. It's 6,562.8 angstroms. One of the spectra of hydrogen. Some filaments down here. I'm going to say coronal mass ejection watch continues, folks. Here's the latest intensity gram. Sunspot 2880 has, I think the leading number is degraded a little bit, but it's mostly remained stable. The most likely place for a major M or X class flare still present. The likelihood of that is still present from sunspot 2877, I believe it is. So here's the latest colorized magnetogram. Yeah, that's still capable of producing major flares. So is this one, although it's more likely to after it moves out of the Earth-facing zone. Next, we've got 94 angstroms from the SDO. A great wavelength to observe solar flares. And we may have to break this out later if and when we see a major solar flare. And we'll close out today's video with 335 angstroms. This is ionized iron, one of the many ionized iron spectra from the SDO. And thanks for tuning in, all of you viewers out there. Once again, please visit the links below the channel, below the video, and support the channel. Congratulations on realizing it exists, and may that solar wind be at your back.